Dear students, you are most welcome in my class. Today we are discuss about a very important topic of your physics, semiconductor. Before discussing about the semiconductor, we have to know from where semiconductor comes out. Semiconductor is a part of solid. Solids are classified in two categories. One on the basis of their construction, where solids are of two types. One is crystal, another is amorphous. In electronics, solids are classified in three parts. Solids are classified in three parts. First is a conductor. First is a conductor, second is a insulator, and third is a semiconductor. Third is a semiconductor. Solid are classified in three parts. One is a conductor, another is insulator, and last is a semiconductor. Conductors are those solids in which electrical charge can be easily flow. Conductors are those solid in which electrical charge can be easily flow. Why? Because in conductor free electrons are available. The conductivity of conductor is very high and resistivity is very low. Conductivity of conductors is very high while its resistivity is very low. When we have discussed about the insulator, has conductivity is very low and resistivity is very high. This is the conductivity and this is the resistivity. In the case of conductor, it is high and resistivity is very low. While in the case of insulator, resistivity is high and conductivity is low. In the case of semiconductor, DM conductivity and resistivity lies between conductor and insulator. The resistivity and conductivity of semiconductor lies between conductor and insulator. Now the time to discuss about the parts of semiconductor. Semiconductors are classified in two parts. Semiconductors are of two types. Number one, extrinsic semiconductor. First of all, intrinsic semiconductor, and second is a extrinsic semiconductor. Intrinsic semiconductors are those semiconductors which are obtained in pure form from nature. Which are obtained in pure form from nature. The examples of intrinsic semiconductor are all elements of those group are of periodic table. But most common example of intrinsic semiconductor are germanium and silicon. Most common example of intrinsic semiconductor are germanium and silicon. But when we are discuss about the extrinsic semiconductor is the mix up of pure semiconductor plus impurity. Pure semiconductor plus impurity. This means that extrinsic semiconductor is obtained when we mixing impurity atom with intrinsic semiconductor. So, on the basis of mixing of impurity, extrinsic semiconductor are of two types. First is a p-type semiconductor and second is a n-type semiconductor. First is a p-type semiconductor and second is a n-type semiconductor. Now we are discuss students, when we mix up trivalent impurity with pure semiconductor, when trivalent impurity is mixed up with pure semiconductor, then we have p-type semiconductor. The lattice of p-type semiconductor is represented as trivalent impurity means aluminium, boron, gallium, etc. So we have take aluminium as trivalent impurity and mix with it pure semiconductor germanium. As you know that germanium is tetravalent while aluminium is a trivalent. So germanium has 4 electrons in their outermost shell while aluminium has 3 electrons in their outermost shell. All the germanium is formed with a covalent bond with aluminium, just like that. These are the electrons of germanium. Germanium is tetravalent, so it has 4 electrons in their outermost shell, while aluminium has trivalent, so it has 3 electrons in their outermost shell, just like H. This is the germanium and their 4 electrons. Aluminium forms 3 covalent bonds with neighboring germanium atom, but its 4 covalent bond is not completed due to the deficiency of electron. Aluminium has only 3 electrons in the outermost shell, so it can form only 3 covalent bonds, but for the completion of lattice, there is required for the 4th covalent bond, and this 4th covalent bond is formed between a hole which arises due to the deficiency of electron. These are the covalent bond, and this is the trivalent impurity, while this deficiency generated a hole. This hole is the majority charge carrier in the lattice of p-type semiconductor, and holes are responsible for the flow of current in our lattice. So students, today we are discuss about the classification of solid, classification of semiconductor, and after that how can n-type semiconductor is formed, it is discussed in our next class. So thank you for today.